What is a transformer? A transformer is made by connecting two sets of coils winding on an iron core. One set is called the primary coil, and the other set is called the secondary coil. When a transformer works, the primary coil is connected to an AC. Usually, this is sinusoidal AC. Then, let's see how does a transformer works. First, when the primary coil is connected to an AC, as shown, an alternating current pass through the primary coil. As a result, a changing magnetic field is produced in the coil. By Faraday's law of induction, the changing magnetic field in the secondary coil will induce an EMF which is produced in the secondary coil. We call this induced EMF Vs. Let Vp and Vs be the primary and secondary voltage respectively. Let Np and Ns be the number of turns of primary and secondary coil respectively. If all the magnetic field produced by the primary coil pass through the secondary coil, we say the magnetic flux linkage is perfect. In this case, we have Vp over Vs will be equal to Np over Ns. That means the voltage across the coil is proportional to the number of turns of the coil. For a transformer, the turn ratio is defined as Np over Ns. If Ns is greater than Np, then the turn ratio will be smaller than 1. Hence, Vs greater than Vp. Or we say the secondary voltage is larger than the primary voltage. And we say this is a step-up transformer. The symbol for a step-up transformer is However, if Ns is smaller than Np, then the turn ratio will be greater than 1. Then we have Vs smaller than Vp, and this becomes a step-down transformer. The symbol for a step-down transformer is when a load of resistance R is connected to the secondary coil, we have both primary currents Ip and secondary currents Is. Also, the secondary voltage Vs. In terms of energy, a transformer transforms electrical energy to electrical energy and heat loss. That is, for power, the input power is Vpip. equal to the useful output power is VSIS plus the power loss as heat. The efficiency of a transformer N equal to the useful output power VSIS over the input power, which is VPIP times 100%. For an ideal transformer, the power loss as heat is equal to 0. Therefore, the input electrical power VPIP would be equal to the output electrical power VSIS. In this case, the efficiency of the transformer, or we say the efficiency of an ideal transformer, would be equal to 100%, or we say equal to 1. However, if there are energy loss as heat in the transformer, the input electrical power VPIP would be greater than the output electrical power VSIS. Therefore, the efficiency of the transformer, which is equal to VSIS over VPIP, must be smaller than 1. How are energy loss in a transformer? In fact, energy loss in a transformer in 3 different ways. The first one is the heat loss, or we say this is the ohmic loss in the coils due to the resistance of the coil when there are currents IP and IS flow through the coils. We have power loss as heat equal to IP square R of the coils plus IS square resistance of the coil. In order to minimize or reduce the heat loss in the coils, we should use thicker coil. Why? Because thicker coil has smaller resistance. Therefore, the power loss will be reduced by decreasing the resistance of a coil. Another way of energy loss as heat in a transformer is that when a transformer works, there is changing magnetic flux in the iron core. So, we have eddy current induced in the core. Therefore, the eddy currents will produce heat. Therefore, heat is produced in the iron core. To reduce the heat loss in the core, we have to reduce the eddy current by using laminated coil, as shown in the diagram. In this case, the eddy current flows through in the iron core. We have smaller loops, hence the resistance will be increased. Therefore, the eddy current will be decreased. As a result, the power loss as heat will be decreased. Another way of energy loss as heat is that since alternating current flows in the coils, Therefore, the magnetic fields in the core change directions from time to time. This effect will produce heat in the coil. To reduce this kind of heat loss, we should use iron core. When using a transformer, the following points should be noted. First, a transformer can step up or step down sinusoidal voltage. Second, when turn ratio Np over Ns is larger than 1, this is a step-down transformer, which means that Vs will be smaller than Vp. However, when turn ratio Np over Ns is smaller than 1, this becomes a step-up transformer, which means that Vs is larger than Vp. Or we say the voltage is increased. Number 3, a transformer cannot increase the power, which means that the output power Vs Is must be smaller than or equal to the input power Vp Ip. For an ideal transformer, they are equal. For a practical transformer with energy loss as heat, the output power must be smaller than the input power.